at your service. Welcome to another math video. That's right. It's the place where, well, we do math. Yes, okay, I'm being honest, okay? There's no tricks here. It's just wonderful math. If you haven't figured out, yes, this is the second video of two videos about percents. So let's go ahead and just review again that learning target that we had, that objective. It says that we're going to be reviewing finding a percent of a quantity, right? We're going to do that as a rate per 100. We've done that. Solve problems involving finding the whole, right? Given a part and the percent. Now let's go ahead and get started. Yes. Dun, dun, dun. Yes, I see you up there, buddy. I know you're back. Hello. Boo. Goodbye. Goodbye. Oh, there we go. So here we are with question number 5. It states 60% of the peppers in the garden are red peppers. The rest of the peppers are green peppers. If 12 peppers are red, how many peppers are there altogether? It says draw a model to justify your answer. My goodness, they do use that word justify a lot, don't they? Justify your answer. So we can definitely do that. Not a problem. I like our peppers here. Something I didn't know, just learned recently as a matter of fact. I didn't realize that the different colored peppers, if you're a pepper fiend, you like your peppers, that the green ones are just not mature peppers. I didn't realize from green they turn to all those wonderful colors. Red, yellow, orange, you name it. Anyway, so we talked about in the last video those 3 pieces, right? I'm going to write them up here. We looked at that we're going to always have a whole, right? A whole part, the whole. We're also going to have the part, and then we're also going to have that percent. And the reason why I like to keep mentioning that is if some of this is giving you some problems, then this at least helps you organize the question a little bit to find out what they might be asking. Now, when they say how many peppers are there altogether, that should be like a big, huge white flag. Yes, over here, please. Yeah, that they're looking for that whole part. It looks like we're going to get the part and the percent. When I look up here, I can see the percent right here. 60% of the peppers in the garden are red. It also states if 12 peppers are red, so it says 60% that they're talking about right there. Cool. So I see this problem. It's kind of interesting. We actually have green peppers that are the rest of what's in the garden. The ones that aren't red are green. And it's interesting because when I think about it, they're not asking us how many green peppers there are. It's asking how many of them altogether. When we're looking for that kind of whole part, we've always taken kind of the percentage, right? Like here we have that 60%. Taking that 60% and we're finding of a certain amount, which we don't know what that amount is. That's the unknown, okay? But we do know that 60% of that whole quantity does equal 12. Now, in regards to red peppers, okay? And that's what the focus is. You right there. Yes, okay? Red peppers. Now, to do our model, I'm going to go ahead and just draw that line like I have before, make it as straight as I possibly can. Kind of showing the same thing. I mean, I look at this, I really do see it's just a tape diagram, but looks like a line. And we've always drawn in our percentage here at the bottom. And then we have also the numbers that are going to go up on top. In this case, it has to do with peppers. What was that other piece that we always have one more number that's available? Either it's the whole or it's the part related to the percentage. And in this case, it's not the whole part. That's what we're trying to find. So it's that 60% is going to be equal to 12 red peppers. So again, we've done this before. Well, with 60%, we can say 20, 40, 60, 20, 40, 60, 80, 100. I have 5 equal pieces here. Of course, we've had some where if you had 25%, we might want to split this up in quarters that way. So this way we know that that quantity here is 12. Because when we have 60% of the peppers in the garden are red, so we can put that 12 feeling confident. Maybe I should put peppers over here. We're really doing much like a ratio. This is what this is. It's just showing on a number line. So now it's figuring out the rest. If 60 is 12 red peppers, and that's cool, then 40 must be less than 12. Then 20 will be less than 40. See where I'm going? I'm trying to use some critical thinking skills here. What I'm thinking is this. I see 1, 2, 3 sections here. And in these 3 sections, it has the quantity of 60%. It also has the quantity of 12 red peppers. Those sections broken up in percentages is by 20. So each section here has 20%. Well, I could also do the same thing. I could take that 12 and think, oh, I could just divide that by 3 sections. Wouldn't that give me 4 in each section? So if I put an 8 here and said, okay, from 8 to 12 is 4, well then from 4 to 8 is 4, 0 to 4 is 4. So it follows that pattern. Well, I can keep going now, right? I can just say, well, that's 16, and then that's going to be 20. And just like that, I've actually just made equivalent ratios is what I've done. Because we initially had that ratio of 12 peppers to 60. Let's see if this is reasonable. This could be the answer. This suggests that we have 12 red peppers here, that there would be 20 altogether because it's based on 100%. Well, let's see if that's really, really true. I could take my 60% again and just set it up like in that proportion. And if it doesn't ask you to draw a model, you can go straight to this. My 60 represents that 12 that was the part, and then this was the whole that I didn't have. Now you might be able to see this right away. You might be able to say, 60 and 12? Yeah, that's just divided by 5. There's 60 minutes in an hour. There's 12 numbers on the clock, 5-minute intervals on the clock. Maybe that's how you remember that. It's one of the ways I remember. 100 divided by 5 happens to equal 20. There's 20 nickels in $1. And now I have 12 over 20. Well, that shows the 60% of peppers, so that works out there. So 60% of 20 is equal to 12. Yay! Okay, here we go. Yesterday, it says that Mia sent 80 text messages. It says she said that 20 of those messages were to her best friend. By the way, Mia, you're famous. What percent of the text messages were sent to her best friend? Cool. Okay. Well, man, that's a lot of text messages there, Mia. Texting away, I see. Okay. Well, I'm looking at this again, I'm looking for a percent, part, and then the whole. What percent of the text messages that were sent to her best friend lets me know that what we don't have is the percent. We do have that whole part of the 80 text messages that were sent, and then the 20 lets you know when it says 20 of those, yeah, they're talking about those right there. Lets us know that's the part. Whole, part, percent we don't have. And when that happens, well, we can list this as, well, 20, and let's write out of because it's not all of them. This is the part. Out of 80 is equal to, yeah, what percent? That's what our problem is saying. 20 out of 80 is equal to what percent? So let's go ahead and, you guessed it, you want to do a good old tape diagram? Let's do a number line. I don't know, number line, double number line, all these little strategies that we can use. Must be the easiest way to set it up, I think. It gives you a nice visual, lets you know what's happening. And then when we have this, we ask ourselves, do we have the part or do we have the whole? Because we already know we have our percentage down here. And what we have is, yeah, we have the whole. We know there's 80 messages altogether. Yeah, I mean, hello. Yes, so now I'm thinking, I do have 20 of those messages, but I don't have the percentage. That's a problem. So, and I'm trying to find that out. So maybe I can have some fun and just say, well, I know that 50%, yep, is in the middle of, 0 and 100. It's half. So if I did half, well, I could just find half of 80, which, there you go, mental math, is 40. And I'm really trying to figure out what 20 is out of 80. So now I know that 40 messages out of 80, that's 50%. So let me just go ahead and find half again. You see how this is going to come out really nice? It is, because 40 and then 0, I'm just finding the half. Half of 40 is 20. So there we go. 20 out of 80 is equal to 25%. Oh my goodness. I just love math. I do like it when things do come together. Math has all these patterns. Math is all about patterns. Hey, somebody forgot to put the numbers on here. 1, 2, 3, 2. Okay. Oh my goodness. Did you just hear the phone ring? No way. Somebody's calling? Get out of here. Okay. Well, I'm not going to answer it. Hey, I'm busy. I'm doing a math video. Give me a break. Somebody's calling on a make-believe phone. Oh, my goodness. Okay. Mr. War, you just... Oh, our proportion. So the way I always say check our work, but it's not like really even checking our work as much as it's just another way you could solve this. 20, that's what we have of 80. And we didn't have the percentage. And I'm just... I notice how I always put the percentage first. I'm just switching it around. 100's down here. This is what we didn't have. See? And when you look at 80 and 100, doesn't work out so nice. But, maybe what we could do is, if I divide it by 2, That might help, but not really. What if I divide it by 20? Oh, I think I might like that. 20 and then divide it by 20 there. So let's just do that. Let's divide this by 20 and this by 20. And then I'm just going to rewrite it over here. Follow the arrow. Okay, so I have 1 and then there's just 4 is equal to 100 down here. And now you can see, what do I need to multiply? 25 to get my 100. Multiply this by 25 and there you go. 25. Oh, the beauty, my friends. Okay. No, I'm not really much of a singer. Trust me, you don't want to hear me sing. So, do we have another problem? I believe so. I still can't believe that phone was ringing. How weird. Okay, so let's look at number 7. It says Lorena paid $120. Lorena, you're famous. For an item after she received a 25% discount. It says Lorena's friend says this means that the original price of the item was $160. Is her friend correct? Justify your answer using a model and words, and then a green line. Oh, that must be for my line. Okay. Woo! I have to say this problem's pretty challenging. Okay, there's a lot going on here. So let's go ahead and look at the problem again, just so we kind of understand the first part. We've been doing this 3 reads protocol, right? Just to understand the story problem. It looks like that basically she's getting this dress over here for $120. Yes? But that she actually received a discount. So she actually paid less than what the normal price. We call the price that she paid for is the sale price. And then the price before the discount or before taking any money off of the dress, we call that the original price. We have the original price and the sale price. So here she got a 25% discount on that dress. So she should have paid more, but she was smart. She bought it on sale. So anyway, but her friend is trying to help her out saying, well, that means this is how much you paid. Well, now our job is to find out if she's correct or not. So we've always been building down our percent on the bottom. That's what I kind of like here. Of course, that's a 0. And then up here we would have the 100%. And then it's a matter of like taking some of that information that we do know and seeing if we can organize it to help us understand what numbers we need to manipulate. Add, subtract, multiply. First thing we do know is that we have these parts. And we have that percent, which we do have a percent up here. We do have, it looks like a part of a whole because the $120 is the part of the whole. We don't have the whole amount. I mean, the whole amount meaning the cost of what the actual dress was, except that her friend said that it was $160. So we could actually use her information. This doesn't mean that that's what the answer is going to be, but we can say this is her friend's claim is that it's going to be $160. But that helps us out a lot because what we can do now is we can start comparing what we understand to that $160. For example, like right down the middle, we all know that's 50%, right? That's just a half. We can put that in. Since we are talking about a 25% discount, we can actually even put that in. Okay, and then of course, why not put the 75% in there since it's right here? So a couple things that we do know, if she had received a 50% discount on the dress, well then wouldn't that mean that she'd only pay $80? Because that's just half? Because remember, this is one thing that's true. Let's come up here. We have 100% is how much that dress would have cost, but we're taking 25% off that amount, leaving us with 75%. So 75% is actually how much she's paying of that original price. The 25% she's not because that's coming off of it. And that's something that we can use here. If $80 is half of that 160, then 25% then would just be half of the half, right? So half of 80 is going to be $40. Well, now we're seeing a pattern, 40, 80, then this would be 120. The question is that correct? Is that $40 off that original price? Well, her friend claimed it was 160, so we could just simply subtract and see. Well, if she's saying the original price is 160, we're subtracting that 25% discount over here, which is $40, and what do you know? Yes, it does. Her friend is correct. Look at that. $120, $120. So her friend is correct because that's 25% off. Another way that I think, like what I was suggesting here, that 75% of the original price is what she paid for, so she got 25% off. So if we could find 75% of $160, that's another way we could figure it out. Let me show you with a ratio. So if we put our 75 over 100, I know, Lorena, I'm writing on your dress. So sorry. Anyway, 75 over 100 then. And we do know that the total that was claimed was 160. Remember that? $160. And we don't know what that, I'm sorry, we do know what the part is. The part is 120. We actually have all the info that we're checking out. Now, this makes it kind of hard to know whether or not this is an equivalent ratio. We could cross multiply, we could do some other things. One thing I would probably do is maybe use some equivalent ratios to make this smaller. So 75, we could divide out at 25, right? So that would be 3. If we divide 75 by 25, we get 3. And then 100 divided by 25 is going to equal 4. And then will that help us out a little bit? It probably will. We could divide out a power of 10 here. Divide that by 10, we get 12. If we divide this by 10, we get 16. Much easier to look. And look at that. Times 4 times 4. It is. These ratios are equivalent. Therefore, her friend is correct. I hope that made some sense for you. I think the big thing is making sure you use that number line, and then also remembering that try to simplify your problem, writing down equations or facts that you know. If you know that 100% would be the total cost of the dress, and you know that she's getting a 25% discount, remember then that means she's only paying then 75% of the value of that dress. And later, and I'll do this one here just to show you in the way that I would figure this problem out if I weren't teaching it this way, but you can also just take the decimal 0.75 and you can multiply it by 160. And if you do that and you're good at just multiplying, that's 0, this is 30, carry the 3, 5, that's 8. I need my placeholder, now I have 0. Okay, now I have carry the 1, I have 2, and then I have 1. Now I have 2 decimal places in here I have to pull out. I have to put 2 in. And what do we get as our answer? Yeah, $120. We found 75% of that $160, and that was the original price. And look at that, we came up with $120. I'm just trying to show you these different ways because I think this is a really challenging problem. But I think always the best thing to do is use a tape diagram, use a double number line. Okay, let's go to the next problem. Now it says, what is 40% of 250? Use a part to whole, I like that, ratio to solve the problem. And we've been doing that on a lot of these already, I think, just because when we were doing the model, I kept checking work. I just wanted to show you both ways because eventually when you get a really good understanding, you're probably just going to set up proportions like what I've been doing. Well, 40% is the part. If it wasn't the part, it'd be 100%, right? 40% of 250. Well, then let's represent that as 40% this way. 40, that's equal to, well, 250 is the whole part. It is because we're taking of that amount. Okay, now we end up with a problem like this. We could always figure this out. There's definitely a lot of different ways you could do it, but we've been kind of looking at it as a ratio, looking across. It's kind of hard to tell what you'd have to multiply, maybe 100 to get to 250. So what we have been doing is just dividing it by a certain quantity. I think if I divide it by 4, that might be helpful. Let's see. If I divide that by 4 and this by 4, I end up right here with 10 over, and then this divided by 4 is going to be 25. And of course, that's still equal to, because it's an equivalent ratio, it's going to equal 250. This is a lot easier to see. Okay, and that's the reason why we do that. Yes. Okay. Ooh, that's a pretty square looking arrow. There we go. So of course I'd have to multiply 10 because 250 is 10 times greater than 25. Multiply that by 10. So see, ooh, look at that, 100. Yeah. Thank you very much. 100. And does it seem reasonable? Yeah, 40% is almost 50%, and half of 250 is 125. And you can see how close that is. So yes, our answer seems extremely reasonable. There we go. Cool, I guess I'm all done. Yes, finished. All right. Happy New Year. Oh no, what's going on? Oh no. Uh-oh. Not you guys again. Oh my goodness. Oh, you had to show off, huh? What? You've been picking up some tricks from the old Firefly? Look at you. Very cool. You guys are funny. I guess. Yeah. Okay. Oh, and I hear the music coming in. Yeah. My music. So you know what that means. Yeah, it's time to say hasta la vista, my friends. Hey, it's been real. It's been fun. And it's been real fun, of course. Now, live long and prosper.